Namaste everyone. In this video we'll be talking about analysis of frames in Ansys Workbench. So this is the frame we'll be taking up. You can see that there are a total of 4 elements on this. We are applying loads at these two nodes. These two nodes are simply supported, which means they are connected with hinged joints. And at this point you can see here we have a roller support which allows only movement in X direction. So let's go ahead and create this. Of course, some inputs have also been given. Let's see them later. So this is the interface of the Ansys Workbench, and of course you'll have to start with static structural, drag and drop it here or double click on it, and you will get this setup over here with a total of 7 steps. First step has already been done. At this we have selected the type of analysis, which is structural, static structural. Engineering data is where you have to select the materials that you want to work with. So click on engineering data sources, go to general materials, and here you will see some generally available materials. By default, structural steel will be added, and you can add any other material that you want. So let's say, okay, so steel is what we are going to use, so we'll not add any other material to this. Next step is to go for geometry, right click on it and choose design modeler. Wait for some time till the design modeler loads. If you want, you can open the show progress bar, and okay, so this has loaded. Now let's go ahead and select XY plane, go for view perpendicular to it, and go for sketching and choose line command to start drawing the lines. So first let us draw a horizontal line, and then let's take dimensions, go for general dimensions, click on the line and leave it somewhere here. The dimension value cannot be changed here. In fact, it can be changed over here. Horizontal length, as we have seen here, is 4 meters. Of course, you need to check out the units here, which has been selected to meters, and here you just need to change this value to 4 meters. So you can see the length has reduced significantly here. You may have to zoom in a little. Now we need another line to be drawn. So go for draw again, take line, click here, and tick a vertical line. Again we need to put the dimensions, so let's go back to dimensions, general dimensions. It will automatically select vertical. The value here we need is 3 meters, so press 3, enter. So now both the values have been adjusted. Let's go for line again and complete the rest of the diagram. So we need a horizontal line here and then a diagonal line joining from this point to this point. So that's it with the drawing of the frames. Now we need to decide what is the cross section we are going to use for this. For deciding the cross section, we should go to concept, cross section, and go for circular cross section. If you observe here, we need the area to be 0.1 meter square. So we need to take up our calculator and we have to calculate the radius for this area. Let's go ahead, take scientific calculator, and we know pi r square is equal to 0.1, so radius is going to be 0.1 divided by the value of pi. Okay, fine. So 0.1 divided by the value of pi, and the result of this we have to take square root of the result, and this is what we are getting, 0.178. 0.178. So this is the radius of our cross section, and here if you see, the radius itself is the input required. So let us feed this 0.178. So 0.178 is the radius. So this has been defined. Now let's again go back to the sketch that we have created, and again go to the concept, click lines from sketch, and then click once on the sketch and click apply. So this will select all the lines for creation of this model. Once you have done that, go for generate, and this will be generated here like this. Once it is generated, you need to click here on the line body, and then here the cross section you can see has not been selected. So here all the cross sections that we have created will be visible. So we have created circular 1 cross section. Let us select that cross section here, and then again go for generate. So that's it. So we have defined the frame, the cross section we'll be using, and the material that we are using by default is the same, the steel. So now we can just minimize it, go back to the Ansys workbench, right click on model and click update. Wait for some time till the process completes. It's going to take some time. Okay, once the process is done, you can see there is a green tick mark here in front of model. Double click on the model to open it, and once it opens, that is where we will be applying all the constraints. So if you watch here, these are the forces we need to apply: 2500 in the downward direction, 2000 in the right side direction. These 2 points need to be simply supported, and here we need to apply a roller support. Let's go ahead and apply all these one by one. So this is where we'll be applying it. Okay, so if you go for mesh, you can see the mesh has been created. Okay, it's slightly larger one than what I expected. Anyway, if you want to change the meshing size, you can just go here, go ahead and change this to medium or something else. You'll have to again click on update to update the mesh. It will take some time and update the mesh. But okay, sorry for that disturbance. Anyway, so you can see the mesh is now generated. We need to apply some constraints. Let's go for right click on the static structure, go for insert. Don't go for fixed support because that's not what we want. We want a simply supported kind of structure. So it's asking us to select a geometry. From here you need to select vertex point, and you have to select this vertex, click apply. You can see a simply supported constraint has been applied here. We need another simply supported constraint. So again, right click, go for here and go for simply supported. This time select this upper one, click on apply, and you can see 2 simply supported constraints have been applied. Here, however, we need a slightly different kind of constraint. So right click, insert, and go for displacement constraint. We know the displacement in vertical direction, that is y direction, is going to remain the 0. So let's go ahead and put y displacement as 0, and of course it doesn't come outside of the plane, so let's give z displacement as well as 0. Now the displacement is only allowed in x direction, so that one direction let's keep it free. Set the geometry, select this point, click apply. Now you can see one vertex has been applied, and you can see all 3 constraints have been applied like this over here. Now what we have to do is we have to apply these 2 forces. So go ahead and apply the forces. Again, right click on this, go to insert and apply a force. So once again you need to select the geometry. Let's select this upper vertex point, click on apply. Now even though you can go with vector, but you'll have to select a direction for this. So my suggestion is to always go for components, and this time we need to apply force in negative y direction. So in the y direction, put minus 2500 newtons as force. You can see the arrow is pointing downwards. So at this point the force is defined. Let's apply the other force as well. Again, select this point, go and apply, select components from here, and this force is in an x direction, so we need to apply that in x direction, and the force is of course positive, so we have 2000 newtons in positive x direction. So at this point you can see all the constraints have been applied. If you click on static structural, it will show all the constraints that have been applied. Now in the solution, we need to add one particular solution, that is deformation. So we want total deformation to be measured, and now it's ready to solve a problem. So click on solution, click on the solve button. It will take some time to do the analysis. It will calculate the displacement for all the nodes and elements, so it will take some time. Once it's done, green tick marks are going to appear for all of these. So if you click on total deformation, you will see the total deformation as it's happening in the mesh. Right. So this is how the deformation is happening. And if you click on the play button, you can see how the deformation is happening in animation. So this completes all your analysis. At this point, if you close this particular window, you will see the green tick marks have appeared in all of them. So all these three steps we have covered in the single model interface itself. Fine. So that's it for this video. If you want to save this experiment for your manual work or something, you can do that by going to the results, and you can take screenshots of this, or take any additional information like the maximum or minimum deformations and all, and accordingly save it. So that's it for now. Thank you.